Adhesion promoters are specialized chemical additives or surface treatments that enhance the bond strength between adhesives, coatings, or sealants, and difficult-to-bond substrates like plastics, metals, and glass. They function as coupling agents, creating a molecular bridge that improves durability, moisture resistance, and chemical compatibility. A coupling agent, a product added to the coating formulation or used in surface treatment, which improves adhesion by creating stronger interfacial interaction between the coating and the substrate, is usually considered as an adhesion promoter. The adhesive bond strength of a coating to the substrate can be increased by 1. Mechanical alteration of the substrate. 2. Polar interactions with the bonding agent, or 3. Chemical bonding, facilitated by an adhesion promoter. They enhance the bond strength either by reacting chemically with both the phases or by altering the critical surface tension. Some of them perform both actions. Additives like coupling agents form molecular bridges at the interface between an inorganic surface and the organic polymer matrix. Adhesion promoters, which make adhesive joints between the coating and substrate, metal or glass, able to withstand the variations in temperature and humidity. They interlock the two phases by reacting with free radicals and atoms at the interface. A coupling agent not only improves the total adhesive strength, but also the durability of the adhesive joint. The functional groups of a coupling agent react with and form chemical bonds between the inorganic substrate and the organic coating/adhesive. They form a zone at the resin-substrate interface with a modulus intermediate between the high-modulus substrate and the low-modulus resin, as well as tighten up the polymer structure and provide groups for bonding to the mineral surface. The following adhesion promoters, which are used in organic coating formulations or in surface treatment, are discussed. Organosilanes used in coating formulations, silanes as additives other than silanes, silicones, and silicone-modified polymers, amide or imide promoters, siloxane adhesion promoters, naphthanates, organophosphorus enamines, organotitanates, zircoaluminates, silyl group containing resin compositions, chemicals which improve adhesion, and other promoters. Organosilanes. Organosilanes have been in use for over 30 years, initially in reinforced plastics and later in adhesives and organic coatings. Silane compounds have performance advantages. Nonetheless, they have certain limitations, such as their high cost, severe hydrolytic instability, and non-optional performance on siliceous substrates. The generic formula of silanes is R'-Si-open parenthesis, OR close parenthesis 3, where R' represents an organic functional group tailored to react with radicals like amino, mercapto, vinyl, epoxy, methacryloxy, etc., and OR is the hydrolyzable alkoxy group. Silane coupling agents have two functional ends. One promotes adhesion to metals and inorganic substrates, and the other is chemically reactive. In use, the silane end gets hydrolyzed in the presence of water and forms a bond after application. The hydroxysilane forms strong chemical bonds with metal, glass, and other inorganic substrates. Polymeric materials get copolymerized with the organic and the silane. Optimum adhesion is achieved with 1 to 3 molecular layers of coupling agents on the surface. An increase in the content of the coupling agents reduces the adhesive strength. Coupling agents are often mixed with resins to make them self-priming. Silanes are normally added in the range 0.5 to 2 seconds of the weight of resin. Organosilanes, as adhesion promoters, pre-treatment primers, or as additives in coating systems, improve not only the bond strength, but also their long-term durability, so that the coatings remain intact under a humid/wet environment. It is noticed that the degree of improvement in bond strength depends on judicious choice and concentration of silanes with respect to the coating formulation and the substrate. Since most of the available literature is patented, it is rather difficult to comment on the efficiency of individual organosilanes. Moreover, the formulations of commercial primers and coatings are proprietary, and the type and concentration of the silanes used in their formulations as adhesion promoters are not revealed. Other types of adhesion promoters: silicones and silicone-modified polymers. Silicones and silicone-modified polymers generally have good adhesion to metals due to the presence of reactive silanol groups in the resin. The mechanism of improving adhesion is similar to that of silane coupling agents, depending upon the silanol reactivity to the mineral surfaces. Silicone coatings are noted for their outstanding heat stability and resistance to outdoor weathering. Silicone resins are also used in relatively large proportions to modify other organic coating resins. The durability of silicones and silicone-modified coatings is also related to the water resistance of silane coupling agent-modified composites. Silicones are relatively transparent to UV radiation, which reduces their sensitivity to outdoor weathering. When a UV photon is absorbed in a silicone coating in the presence of water, siloxane or alkoxy, silane bonds are hydrolyzed with the formation of silanol and carbonyl groups, which are capable of reforming siloxane or alkoxy-silane structures. In this way, the coatings can absorb high-energy radiation in the presence of moisture without suffering irreversible damage. Amide or imide promoters. N-chlorosulfoalkyl, arylkyl, or aryl acid amide or imide has been found to promote the adhesion of vinyl-based adhesives for metals, wood, and plastics. Plastisols based on vinyl chloride, CO polymer, which contain a polyaminoamide, a condensation product of polymerized fatty acids and polyalkylene polyamines, are reported as an adhesion promoter. The addition of a condensation product of a polyamine amide and a carboxylic acid or ester improves the adhesion of polyvinyl chloride plastisols to metals. Polyaminoamide resins prepared by condensing polycarboxylic acids, obtained by the polymerization of unsaturated fatty acids, with piperazine or an alkyl amino derivative, also promote adhesion of plastisols of vinyl chloride, CEO, polymers. A formaldehyde adduct produced by reaction of an amine or amide or their adducts with ethylene oxide, an alkyl, cycloalkyl, or aryl substituted ethylene oxide or cyclohexane oxide is claimed to improve the adhesion of asphalt compositions. Siloxanes. A polyorganosiloxane containing alkyenyl groups, a polyorganohydrogen siloxane, a platinum-type hydrosilylation catalyst, together with a polysiloxane, diorganohydrogen siloxy, alkyl and siloxane units has been used as adhesion promoter for curable organosiloxane compositions of transparent coatings and adhesives on various substrates. The polysiloxane is prepared from a trialkoxy silane and a polysiloxane with a silanol group and acts as an adhesion promoter. Naphthanates, metallic soaps. Iron naphthanates have been used as adhesion promoters for bitumen and in anti-fouling paints, whereas lead naphthenate and zirconium soaps, for example. Octanoates or naphthanates are used for alkyd paints. The use of zirconium propionate, especially in solvent-based cellulose acetate propionate-based printing inks and waterborne coatings for improving adhesion, is reported. Scientists found that zircoaluminates function as adhesion promoters when used in high-solid polyesters, in the intercoat of acrylic or melamine coatings over phenolic primers, and in epoxy systems. The Cavedon Chemical Company patented multifunctional amino-zirconium aluminum metallo-organic complexes as adhesion promoters for coatings, adhesives, and sealants to a wide range of substrates. Zirconium Schiff-base block copolymer coatings have improved adhesion to silica and aluminum metal. Organic titanates. In recent years, Organic titanates have been used as surface-active materials for adhesion promotion, pigment surface modification, dispersion improvements, and rheology aids. These compounds function similarly to the silicones and offer certain advantages. The Cleveland Society for Coatings Technology studied a series of organic titanates as adhesion promoters for steel surfaces. Their findings indicate that titanates with certain organic moieties are superior in promoting adhesion. It was also shown that the favorable or adverse effects of titanates on the adhesion of an acrylic thermoset or thermoplastic coating depend on the position of the organic radicals substituted to the titanium atom. The best performance was shown by the addition of N-ethylamino titanate, and the worst by octyl phosphato titanate. Organophosphorus enamines. Scientists reported a new class of adhesion promoters that contain a trialkynyl phosphine oxide obtained in 84% yield from phosphorus oxychloride, having acetylenic groups activated for quantitative addition of an amine. The polyfunctional triamine in thermosetting epoxy resins improved adhesion, tested at 60 degrees Celsius and 100% relative humidity on glass. Ford Motor Company patented organophosphorus enamines comprising tris-2-alkylaminovinyl. Phosphine oxide or sulfides are useful as epoxy curatives and adhesion promoters. Zircoaluminates. Zircoaluminates emerged in 1983 as a new class of metal organic adhesion promoters. They are highly reactive with a diverse array of substrates and do not suffer from the hydrolytic sensitivity of the silanes. They improve wet adhesion and reduce concomitantly corrosion on metal surfaces when incorporated into solvent or waterborne coatings. When incorporated into adhesives or rubber compositions, they improve their bond strength to difficult substrates. Hydroxy-bridging linkages are formed between the zircoaluminate and sites on the metal surface. Subsequently, the zircoaluminate carboxy group undergoes condensation with the resin terminal hydroxy groups, resulting in chemical linkage of the resin to the substrate through a zircoaluminate chemical bridge. Silyl group containing resin compositions. A silyl group incorporated in a vinyl resin composition consisting of a carboxylic acid, amide copolymerized with a vinyl polymer backbone, and an organotin or carboxylic acid anhydride curing catalyst improves its adhesion. Silyl groups, at least one per mole, are incorporated in malec anhydride during or after copolymerization, and bound to hydrolyzable groups give coatings with high gloss, good resistance to weather, water, and solvents, and improved adhesion. Miscellaneous adhesion promoters. Gallic acid or gallate ester was used to enhance the adhesion of 2-cyanoacrylate adhesive compositions. A tris-epoxy propoxy methyl isocyanurate compound was claimed to enhance the adhesion of adhesives. Coatings from polyarylene sulfide containing manganese dioxide in the first coat have improved adhesion to the metal substrate. According to the method developed by Mitsui Petrochemical Industries for improving the adhesion on polyolefin, the molded articles are dipped in a synthetic rubber, dissolved or suspended in a halocarbon solvent. Small amounts, 0.05 to 3%, of an amphoteric compound, for example, N-N-octylglycine, will improve the adhesion between paint film layers, according to the Nippon Paint Company. Substituted hydroxybenzylamines used to pre-treat metal surfaces before painting give better adhesion, according to Axono Incorporated. Copper oxychloride and copper magnesium. Oxychloride were used as promoters in sealants based on bisphenol A epoxy resin, furfuryl acetone monomer, amine hardener, and fillers. Small amounts of acetic acid, IN adhesives containing 2-cyanoacrylate improve their adhesion. The adhesion of ethylene glycol and sodium alkyl or siliconate in acrylic dispersions leads to an increase in their adhesion strength. Scientists investigated the effect of some adhesion promoters on the adhesion of shellac to metals, iron, copper, and brass. They observed that maleic acid behaved better than other promoters. It imparted a bond strength of 0.3 tons per square inch, whereas plain shellac has 0.08 tons per square inch when bonded at 150 degrees Celsius and 2,000 pounds per square inch pressure on a steel surface. Additives like silanes and other types of coupling agents used in organic coating formulations or in surface treatment promote adhesion by forming bridges at the interface between an inorganic surface and the organic polymer matrix.